Hi there, in this video, we will learn how to create the CRUD application in the Rust using Axum, Axum framework. So let's start and we build the simple CRUD application. So that is most common and most important. So basically, when you write your API, when you create your own API, so basically at the end, like more like at the end, you are doing the some CRUD application, right? Like CRUD thing, like creating, updating, deleting, and updating, deleting. So that is the most basic thing. And when we learn this thing, like that is the CRUD thing. So on the top, we can learn more about a multiple thing, like after that you just learn the system design, and or maybe you can how you optimize your code and how you integrate Postgres, how you call your databases. So that is basically you just optimize. So yeah, definitely I will go on that. Definitely, I think next video I will also integrate the databases. So in this video, I will more focus on the like how we can create uh, like simple API application, like how you create your routes and create routes, get, post, put, delete, all these thing routes. And I will also test with the Postman and how we can return the error, everything like that. And we store inside the app state. So basically in there some cases I think rate limiting, I think. So basically you can just create your own state, and basically you can just store the how many people just call your API. So basically for the specific routes, or might be like for your for whole application, how many times you just called for the specific user, or might be authentication, authorization. That is the most I think uh, that is used. So when we learn, this is the like most commonly heavily used, more basic. So basically fundamentally you already know like at the good level, so without using any AI tools. So I think it can help without uh, for writing your application. Okay, let's start. And so we have just created like a simple application. Let's set up like cargo, new, and task. So when you write this command in your terminal, so here you can receive some cargo toml file and some src.main.rs file. That is the basic thing you will receive. So before that, first I will go in the cargo toml and first add the some dependency. So first go cargo.toml, and Axum is the framework for the writing your first backend framework. That is basically when you write your application API application, when you write your API route. So basically Axum is the modern framework. So it will help you to write your backend application. So we can add the cargo, add Axum, and we can also need the serialization. So also we add the Serde, and Tokio is the asynchronous runtime. So we should also include this. So cargo add, we just add the dependencies. So it will adding. So it is just adding. So Axum we have the some feature like macros we required, like for the suppose we need the like handling, and we are not no idea what is happening going on, so we can use the div handle. So I will also show the some demo. So I just want to also include this feature. So basically in some, so you will more familiar with that, how you can see the actual error. Like it will give us like a little bit more like I'm not exactly showing, but yeah, I will give you some idea how you can and do this. Macroach Serde have the features version. It have some derive. So basically it derive features. So basically it will derivation, like it like Serde is just that's the core thing. So basically what actually do like for distillation of like a JSON and in, or maybe in other format. So like we need some derive feature. So basically it will just derive on that what you need on what responses. So we should also include this one. What is the feature is the derive. And Tokyo is the student's full time, so it's have multiple features, but uh, I don't want to go every in depth. But basically, when you write your own application, so you should focus on what you need, what you don't need. So when you in a production, you should to understand what is important, and like it's uh like you should to know, right? So what is needed. So basically, you have the less dependencies, so it less take time to for compilation, and might be cost efficiency, I think maybe like 5 MB. So if you reduce maybe 4 MB, so when you deploy on somewhere, so it will cost less, I think it might be. But yeah, you can also think like that. Another is Tokyo. Tokyo is a feature. It could be the full. I need like 4 times the full. For this thing, definitely I will also share more about an upcoming video. So, but I'm more focused on the Rust backend developer. So I'm going step by step. So if you see my previous videos, I also talk about the like path extractor of the Axum. Important JSON. Also, I talk about how going return in JSON format to the client. I also talk about the query, how you can query your data. So like suppose the data is coming from the client side, like in query form, so how you can extract the data and how you can act on that on the variable, like query variable, right? I also talked about like macros. Also I talked simple routes. Also I talked about like you can see the previous video, you were more familiar with that. So yeah, so like I just create the first like I just want to give you a step what actually we'll do. So first one, step first me I will just create a simple application, create a simple server, like basic thing like how to run your server. So basically that is what is required. So like we just import all the thing, and we just um, run the server, and it will just run the application. So we create a simple server using Axum, that is right. After that we will create a state. So basically like suppose data is suppose post, so what task is created. So basically it will store inside the struct. So we will define the struct and some data inside it. Like basically we will store inside the HashMap. So basically key and value pair. So what ID and whole object will store, will go in the value. So hash about key value pairs that will store inside the state. And okay, create a simple, not simple, create a F state, not simple. Yeah, create F state. Here we are using the hash map, so storing the data. Why we are using the hash map? Reason is like we can for read over one, like it's a time, like time complete will be one. And if I use the vector, like some like array format, so it will go like like I want to access some specific data, so it will go somewhere like it will just go one by one, like its time complete will on one. So like just go and it will just check, okay, this ID is inside this array or not. So instead we can directly directly will check the ID, and ID is just fast like O1, and it will give okay, that is the data, and it will go in the object, and it will just give the data, right? So instead, so we are using the here Heisman. We can also use the vector for the agent vector in that, in like VC is like for storing the data in the array format in the Rust, right? And the JavaScript viewers, Okay, so that is the case. So first create a simple server, which then create this type state. If you create a routes, create a what route? Route would be the like task route. For the create a task route for what is your task? For your routes. For task route, create a slash route for the task creation, for task creation. And second, for and fourth, oh god, what could be the read the task, read the route. Okay, read a slash task route. Here could be the gate. You will write it, this could be the gate. Here we can read the all tasks. And fifth would be the update. I will just update the task. up, update the task. Here we can use the, what can we use? We use the put update the task. And sixth, I will delete the task. Basically here we can use the delete methods. Basically that is all about. If all this thing done and we and test with first 7, definitely all thing will test by first one, test by first one. After in this video I will talk about in these 7 steps, and after that, like upcoming next video, so I will talk about the integrate databases. So basically here be all access data is coming from the state, and it's coming immediately, like all the data will come from the databases. So like I will also, instead of creating a different application, or might be we will create a simple basic application and store in the databases. I think that could make sense. So basically I will write the uh, code from scratch in the next video. Yeah, that makes sense. Please give me. Okay, let's see. Just write the comment what is the best thing, like writing from the scratch to integrate databases, or might be we can directly when we just add this application. Like I will just extend these projects. No idea. Might be, yeah. No, no. Okay, let's see. I'm thinking like I will write the code from scratch. That makes sense. Like instead of like create the application, we can directly write the simple example route and store in the databases. And I think we can extend more. Write in the comment what is the best thing to learn. I have no idea. I'm just exploring what is the best option. Like I also write a mini code, multiple codes, multiple like what. Okay. I don't think it is a thing to require to say everything about it, but I enjoy talk like that. Yeah, okay. So you already know how to set up simplification, like Tokio is coming from, we already define actually and added in the dependency. So first cargo will, why cargo will do, because of I added some features, so I just want to all the important stuff, so it will also give the error if something happen. So Tokyo here could be the main, and I just want to import anything. We can import, but I don't want to import anything. Like it will directly give the import, like we can press the option and spacebar, it will, I can import directly instead of manually importing, so it will automatically will import. So first I will create a simple server. And what is the router? I already talked before. It is just the composer. Composer is just like all the routes will compose in the router. Like basically multiple routes, it will combine into one route. Like we can think like that. Like router is just a composer. Just compose all the routes in one route. Just for understanding. So like here, and all routes here we can create multiple routes. Oh God, route, and here just a simple home and get. Here we can just call the async, and here we can just return the hello world, and simple. Okay, I think it should give there. Okay, it is saying hey, get is not coming, so press the type option plus press bar, so it will give the option, and here you can import the, it will come from routing and router. I will already talk before in the depth, router routing, what is that. So if you're not familiar with it, I highly recommend you can just watch that video. You will more familiar with that. I'm just saying, it's your choice. So listener, what is a listener? Listener, what is the what port on the, actually is listening. So what is the network? Network route to be TCP listener. HTTP 1, HTTP 2, both are running on the TCP listener. We use the TCP listener, TCP, and UDP. UDP, I think HTTP 3 is run on the UDP server. UDP, yeah, UDP something like that. HTTP, UDP. You can explore. Okay, this is binding. Binding could be the local host. You could do 1, 2, 3, 4. and it with the what is the port would be the 3000s. It will run and it will wait because of it is the asynchronously, and it will after the returning, so it will unwrap. I don't think we need to require, but when I unwrap, so it will only return the TCP listener. Otherwise, it will just return the result. So I need the return a TCP listener. So we can here you can see now. If you're not seeing, let's see here. Wait, so it will give the result TCP listener and error. So I know it will return the 3000 word port. So it will not already know. So yeah, it is a local. Might be in the productionized we can do something like handling, like error handling. Hey, might we give the error, so like this pod is not running or something else on the production, so might we do handle like my something, but for now we can just unwrapping the value, and we have TCP listener right here. You can see this is the TCP listener, poly vented TCP socket server listening for connection. You can accept a new connection by using accept method. Anyhow, I don't care, I just want to run the server. Axum the serve. Here you can pass the serve, like first one was the listener and another is the route. So I think a bit, and here you can return. I think not necessary, but yeah, why not? Like okay, and we just get the simple routes, and now you can just go the hello what not hello what hello Nishant, how is it going on? So I just create a simple, this is a closure. Why not? If you don't know, this is a closure, and after that we can write this one. I will talk more about, like I'm also a little bit, I'm thinking it is important to explain this thing why hello Nissan, this is a closure when you write something like that. Okay, but for now just for understanding, that's when you write that I'm just testing. Okay, slice. I just wondering what is returning. Cargo run. Okay, that application is running, but it is not. Okay, we should also write the print ln. My application is running. Ah, server is running on port. No, 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 that is not right. Server is running. Uh, server is running at. And here we can just pass like that. Listener dot, I think local address and another, and that makes sense. If I just run it directly, so 3000. Okay, it is saying here this application is running on 3000, and now I can just go the 3000s, and here we can just test it. So it is saying, hey, hello Nishant. It means the my exercise. Okay, actually I was testing before creating this videos. Okay, so hello Nishant. So basically, my application is simple application is running. Okay. Okay, so what is the same thing? Creating a simple server organization. So we already done it. And create a app state. Create a app state. Okay, we just create a app state. So how you can create your app state? So basically, it's nothing but just a struct app state. Okay, and we need the, like a store inside the HashMap. So okay, so what is the like tasks? This is the task, and here we can it could be the uh, okay, we can write first I will tell you like what data inside the hash map, like what object look like. So I will say task state. So basically, like I'm saying why reason is like when you disguise and when you returning or when you are requesting what data is come from the client. So basically you need to separate this a state. So basically you have the separate struct. So basically what will return, what will request and what will return. So basically it not necessary to uh, do every struct to disguise and disguise. So basically you have this already have the stat ask like especially for the task. What task would be inside, like first one definitely would be the id would be the, I think I want to keep the yo 32. No, I want to 128. Okay, so what could be the content inside task? You know, you have searched the Google task.com, task.google.com. So it is like it's just give the simple you know, like here you can just write your text and like this one is like here you can just add task and you can just write your task, add your task here, add your task, and just put like you just adding your task, right? So like we are building something like task.google.com. Have you searched it? Just try one. So basically, you know, in the context we are putting the actual data, and I'm not you know, I'm not I'm not doing anything like a max content would be something like that. I think we can do this, but I don't want to. Like you can write your own content, like how many data you want to keep, you can keep. And two things he doing like here you can add your own state, but for now I just want to keep the ID and context. Here you can write the created at when we store in the database, so definitely we can do this, but I want to keep that just for now for familiar. So when you see the next video, so you will more familiar how in databases how it store. So created and updated at just edit target, and here becomes for deserialize derive serialization deserialization. So basically it will serialize deserialize, and now I want to keep the all this state this object in the HashMap. So a struct and task has task has task has map task has task has. So here could be the task, and it will be the has a map, and what is the data type? Data it would be the task status. So basically key value. Oh, say, so you know key value. So here would be the string and another is the task. So this is the key and value of the objects, and here to the id, like here would be the id type is the like string, so here stored inside the like hasmap id, and so for the accessing the data for the task, so we directly call the id, so we can return the id, like we can access the by id and it will return the value like task. So basically this object stored by the there this id, like this id will point it to that like task value, like its whole object. So id would be here and whole data bill goes here, and it will store in the key value, like key would be the id and value would be the whole object. So I am storing in this like that. So here we can do the derive, and it will the serialize and deserialize. Here could another thing we can clone is also important. So in some reason, yeah, some reason, like you know, cloning is nothing but it will just create the separate separate memory space in the heap. So we can do this. Instead we can do debug. For debug is also important. Clone we can, but I don't think it is required here. If needed, definitely I will write here. Debug is for, you know, when you printing, and it will help you debugging. So HashMap directly store the HashMap, and now we create the actual app state, and here would be the uh, what is the what is the if I write the app state and inside like tasks and tasks and it would be the like mutex it will just log the data. So when like multiple requests is coming, so what is time like some 100 requests, so it will just log the data what request is doing, like some request is like updating the data, so it will just log the data. And if that done, so like betting request will do stuff, so we are logging the task, logging the data. If I just we can't do a struct, so basically it will log the data, so it could not be the serialize or deserialize, so we can't do that. Another thing you can think, like I should to give another name, like task has state. So task is the data and this is the thing. So basically it will for like suppose you want to access the data. So basically you will access all the data task, all the tasks. So that task is like HashMap. So all the access the key, all access the value. So basically we will serialize like for the accessing all the tasks. So here I want to give something a state, like state like this is state, and that will actually the log the data. So for now, so I can't give, if I give the serialize deserialize, so basically it will not happen. I will show you, but for now you can just assume it will not give, because of all I have experimented before. Like I already write code, so if I do stuff like it will give error. Okay, I will show you why and how. He is saying, hey, struct task is never constructed. What does it mean? I view task state, task state here using, and still it is saying, it is saying something. Warn date code part of. It is saying, hey, code, not easy. Okay, it's like so. I'm doing comedy. Okay. Okay. I have a state is already created, and now I need to import this. So latest state is equal to arc. I already talked previous video. So arc is just increase the reference count. It is not the uh, in the normal Rust, what actually Rust does. What is the rule? Like every variable have the only one owner. Like every value has the only one owner. Like if it can't be multiple owner. Like ownership references is the core thing of the Rust. So arg is just for multiple threads. So it is just increase the reference count. Like suppose late is equal to 2. For now, suppose example late is equal to 2. Okay, so this 2a is the owner of 2. Like b is the also owner. Like here we can see let b arc dot clone. Here can write the a. So so basically v is also referencing to the a. Basically this is not the right code, but just see the context what I'm saying. Like b is the also owner of 2. So basically arc is just to increase the reference count instead of when you write actual clone. So basically it will just create the separate already in here I said when I write the clone. So basically it will just clone what it will do, it just create the separate memory space in the heap. So I'm not doing this. I'm just referring the same source, but it just increase the reference count. For that, so like at a time only one request will handle this. So for that I'm just using the mutex. So basically at a time actually log the data. So arc is coming from where? From where is arc is coming from here? Sing songs. Okay, mark arc dot new, and here inside the arc. So here what we do, I will directly pass the data. What is the data? Data is nothing but just type state. And so what is the default value here? So here we need to type the press the option plus specify to give the option. Okay, the state, and state would be the mutex dot new, and here is the uh, actual value. And what is the value here? Just see mutex like here HashMap, and HashMap could be like that is inside the task, and we have the some 1 second, what is that? Okay, and that is the test state have mutex. So already define the mutex. Mutex and the mutex have the state, and mutex have a task state. So basically it is the task, and that is stored inside the task hash. So like this one would be the inside the mutex. So task state, and that will the task, and here would be the say like tasks, and that would be the by default. So basically saying this data would be the default, and that would be the like what is the HashMap. So HashMap dot default. What is the default? Like that is the thing, like key value, like simple like by default, like just a key value, but it is nothing else. It is inside that nothing. So right. So we just define the state. One time again, I just want to explain you. Uh, Here you see live state. Create a simple server or return. Create a state. We just created the state, and this is the task what the object inside the value in the object like key a value. The value have the task state. It will store like what is inside the task state. So that is the inside will, and this is the task like what we actually stored like task has a state. So as this is a id would be the string, and a whole object would be the like this one. So id while like store, and this is a task like we can access all the data, and we can also initializing and serializing. But here we already said before ki we can't serialize because of that actually mutex is log the data, so we can't serialize or deserialize. But here is a JSON format, so it will serialize and deserialize. Here it could be, but here we can't. So basically it will log the data, and we'll also show you we can't do this. Uh, so like app state, and here we just define the si state, and arc is just increase the reference count. So increase the reference count, and app state is the mutex, so app test, and this is the mutex, the data, the actual data is here. So this data will be the lock, this data actually lock, and it will store the inside the hash. And when we like share the like multiple routes, so for that we use the some clone, so arc double colon clone. So instead of that, not necessary to we are using the like bth state, so that will handle this. But arc is just increase the reference count, so at a time only the one request will do stop if all done by the one specific request, or maybe one thread. If I'm doing the like if I just if you're doing something separate, some work like some threading stuff, so one thread will done, then next will wait, and if it's okay, done, so that was waiting, that was for someone waiting, so that will wait, and that will just come, and it will just work their work, and another other request will just wait, and then if done, so then again it will just so on and so on, it will just thread will go on, so it will just log the data at that time, and other will wait. So that's the state, and that is the that what is default like hash map, like just a key value. I was just saying ki, hey, you can't do this. Hey, first you will just add the beta state. So what is the route have the beta state, beta state. So basically we no need to pass the clone like we are passing share state. So that data is coming, and we are just passing to all routes. So we just pass the all routes with the state. And I said ki, hey, we can't serialize. If I write the derive, and we can write a serialize. So serialize, and other is this deserialize. I write, that is good, nothing here, and I will create the routes. I don't think it will give error for now, but for now, I want to show you just create application, and then read the state, and then I will show you why I'm doing why I'm saying that. So here you just give the hello Nishant. It will not give the like basic simple thing, right? I'm not doing any extra thing. I will just create a state, and just define just declare a state, and we are just passing the state, and here we are saying ki we can't serialize and deserialize because we just log the data. And that is really important to know about like why I'm doing this, why not directly passing that. It is sometime feel like why it is happening, But when we understand the concept, why doing like I understood, we can't serialize and deserialize because of this is a locking the data. So in that case, we can't serialize and deserialize. It might be wrong, like I was doing, so that time it just gave the error. So I'm assume ki it will give the error, but for now I just gave the serialize and deserialize. And I was just assume key we can't do this because of it just log the data, log the state. So that reason it might be we can't do serialize and deserialize for that step state. I might be wrong. Like so that time realized okay, app state is a locking data, so we can't deserialize. But here I just gave and already getting the application and it is working fine. And now I just create the routes. Just want to show you. So first route would be the task or task and it method would be the post and what is the post create task or I think create task, update task, delete task. So I think I should to create task or add task. I think add task make more sense. Add task. Yeah, create task, create task, create task. Okay, create task, create task. So I just write the handler, just I define the handler. So it is saying, hey, post, it should be come from the routing. And now we can create the handlers. So handlers would we look like? Handler look like async function, and here could be written the something result, and here would be the some types. What would be type? Type could be a string, and errors would be the something a string. I will change it, but for now I just want to task. Just create task. So what would the first would be the state. State would be the here with the state. What is the type? Type would be the state, and type could be the what is the request data is coming. So that is the task state, right? So here we can pass the task state. S- but 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 instead of that we are passing task state, we are passing the actual state, like basically what is a mutex, like basically what the local data is locked. So here we can pass the actual state, like here we can pass the app state. So that data will updating, deleting and everything, so it will just log the data and it will just update and stuff like on according to that. So we will just pass the state, and post we have also uh, pass the data from the client side like Postman or maybe some front end side. So basically what data is coming, so basically we are passing the data and data is come from the client side. And what would be the type? Definitely it would be the type would be the task state. You know that data will come from the client side. And what would we return? So definitely it will not return the like a string. So we will create like different like another routes, another struct, and where should to write a struct? A struct would be the task response. Like it is the common response. So first would be the ID. ID would be the 128, 128, and another is the message. Message would be the string, simple string, and it would be the serialization. Derive. It would responsing to serialize will work. Not necessary to give the deserialize. Deserialize when your data is coming request and it will return convert in the struct form, and serialize will just this struct convert into the response. What the response? So like that is the response. And here is the task response. So basically I will returning and it will look like this JSON format. And he's saying hey it is not coming, where is data coming from? So like that it's coming from the JSON. I already talked previous video, previous some video. So it is come from JSON. It's just if this data is come from like some state, so it will just uh, it will just convert in the JSON format, and you can easily access the data like in the JSON, and you can do stuff. And if you want to return, so you can also do stuff. And if an error come, it will give the error string. Then instead of that, I should say, hey, you can also pass the like task response like ID. What ID is come? I think no. We can do this in that, but instead of that, we can something. We Oh God, we can do something like first we can pass the like status code, and another we can pass the something JSON. But here task response by passing the ID, like suppose errors come, the ID we can pass, like suppose creation is happening or someone pass the ID, suppose ID is already exist, so in that case we can pass return like ID already exist, and it will return the ID and also return the message and status code what is give there. So we can also return the same thing, task response, but here it will give the like ID and also respond the message. If something error, we can handle this after that, or might be status we can return like ID and message. ID could be anything, like could be anything, none option, might be anything. When pass there create task, only ID is required. So we just define the state JSON, and we are just returning the result. Result, it means it will give the two things like okay, that okay, we are just returning the JSON format like here you can see, and another is just saying hey error. The error could be just returning the two things like in a tuple format. Like first, status code, like error is just thing like this look like a tuple like, but the status code it will just show in the headers, like you will see the here when we return a status code. So here you can see the what the status code is come. I might be headers here because I no idea. Like let's see, I will see. And actual data will come from like come here like Nishant, where you can see. So okay. So that is the task. We just define all this thing parameter that is required and create task. So first case, what was the first thing like first task creation. So first log the a state. So first a state is equal to like state dot log. So basically we just here you can see I just give the name of the task, but here you can give anything, but task that's the state, and state is come like all the data is just a step up state, and
It's
that is a
3
log.
o'clock.
So like it will just log the data, and we can just wait. So it is saying, hey, we can't wait because it's not like why? Because mutex is come from the synchronous, like async std library. So instead of that, we can import from the Tokio. So like since Tokio is a synchronous runtime, so use Tokio and sync. I think that is on the same here like mutex, and instead of that we just import it, and it is saying it will definitely give the error. Okay, let's see. Here is saying, hey, the trade one Tokyo async mutex has what. So I said before, ki, hey, you can't do this, right? So why mutex is locking asynchronously? Like suppose multiple requests doing a stop, like at a time, like 100 requests. So in that in this scenario, so it's just log data and locking data and mutating the data, mutating the state. So it's saying, hey, why trade one lock your sync serially deserialize the is not satisfied. For local type consider derive serialize to your Tokyo sync mutex hashtag type for types from the other crates. Check whether the crate offers Serde feature for like we already define the Serde like in the selection distillation. So it's saying, hey, you can't do this, right? Synchronous. Here's the asynchronous. That is not a synchronous. Here you can see that was a synchronous by like non-blocking. So here you can that was a blocking. The here you can this is the non-blocking. So basically, it is asynchronous mutex-like type. This type acts similarly to std sync mutex with two major difference. Log is an async method, so does not block, and the log guard is designed to be held across dot await. It will wait. And Tokyo's Mutex operates on a grantee FIFO basis. FIFO in first in, first out, right? FIFO, first in, first. I think a stake. I think first in, first out. A stake. I think a stake concept. Q. I think, first in, first out. FIFO. I think first in, first out. That is the stake. I think first in, first out. No, no, this is a queue. And LIFO, I think last in, first out. Last in a stake. Last in, first out. That is a stake. Last in, first out. That is a LIFO. LIFO basis last in, first out. That is a LIFO. FIFO, it is just the queue, like first in, first out. Okay, that is a queue basis. Okay. This means that the order in which the task called the lock method is the exact order in which they will acquire the lock. So like basically basically both are doing same like what is needed, but this is a synchronous manner, asynchronous manner. We can also here you can read which kind of mutex should you use. Contrary to popular belief, it is okay and often preferred to use the ordinary mutex from the standard library in asynchronous code. Yeah, what is it? Contrary to popular belief, it is okay and often prefer to use the ordinary mutex from the standard library in synchronous code. Matlab, it doesn't make sense, right? You can use the anyone. Uh, it is okay. Okay, often prefer to use the ordinary. Okay, okay. What is it? Where is that? Where is that? Where is that? Yeah, where is that? Okay, that is not. Mhm. Oh, where was? Oh God, where was that? Okay, that is it. That is it. No, 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 no. Mutex, Mutex, Mutex. What is saying? The feature is async mutex often offer a blocking mutex. The feature that the async mutex offers over the blocking mutex is the ability to keep it locked across dot await point. Here you can see dot await point. This makes the async mutex more expensive than the blocking mutex. Okay, that is more expensive. So the blocking mutex should be preferred in the case where it can be used. Okay, that makes sense. So where we can use the what is needed. The primary use case of for the sysing mutex is to provide shared mutable access to IO resources such as database connection. If the value behind the mutex is just data, it is usually appropriate to use a blocking mutex such as one in the standard very parking lot. Not that although the compiler will not prevent the std mutex from holding its guard across database point in situation where the task is not movable between threads. Where the task is not movable between threads, this virtually never leads to correct concurrent code in practice as it can easily lead to deadlock. Okay, a common pattern is to wrap arc mutex in a struct that provides non-asynchronous method non-asynchronous method for performing operation on the data within. Uh, okay, non-async method for performing operation on the data within, and the only log the mutex inside this method. The mini redis example provide an illustration of the pattern. When you do want a shared access of input output resource, it is often better to spawn a task to manage input output resource to message meshing. Use message passing to communicate with the task. So Tokyo essentially is just mutex. So just clone beta 1 mutex, just create the mutex 0 and clones basically same source. So it is saying we can't trust what is needed in what cases, what scenario. So on that you should to use instead just believing what is right. That makes sense. But for now, we are doing same thing, right? The mutex is wrapped in SC arc to allow the shade across thread. Each span task of 10. So for that, yeah, we can use that, right? No, but weight is little bit more expensive. So what do you choose? Depends in condition. Uh, okay, okay. I just wait. I'm just waiting. like that is the waiting. Okay, I'm just wait, but I just want to put it, so first I want to check if not a state dot task dot contains key. What is the key? From where data is coming from? Data is coming from data dot id to a string, and it would be the reference. If it is a state it not contains the key. Uh, okay, no. If not task dot contains is not already in that the has, so we can store inside the hash. So let data is equal to what is the uh, what is the task. We can like redefine the task. What is the task state? So task state task state had with the id, and id is come from the data dot id, and another is the context. Did it will also come from the data from context. Another is the created it. So here we can give the like definitely it will come from the client side, and another is the updated it. It also come from the data dot updated it, and question mark. Okay, why it is saying hey it is giving error, so it is saying hey you should to mismatch, so found the return and you are just returning something like that. So yeah, we can do something like uh we can give the else, right? So, and here we can show the error something, but for now first should be should to complete this one. Okay, okay, first I write the okay, or maybe we can write the to do. I think that makes sense, like other like remaining work, like to do is just like I have the thing I will write. So I just write the to do, like I have the I have remaining, I have remaining task to just do stuff. So like I've just defined the task, to give what the data inside we will keep. And now we have the state. So basically inside task we can just insert what would be the key would be the data dot id dot, I think, clone. I think it makes sense. Okay, that would not make sense. I do the like 232, so basically to the string. So first I will change to a string, and it will store task. It is giving it. I think if I just remove the clone, it makes sense. Uh, Not response. It is not giving it. I was talk about like why is giving. So basically we are it is saying talking assume mutex. So this is not satisfied locally. So that occasion we are importing from the Tokio. So that reason it is giving error. Okay, I just want to clear it. So make sure what is doing. What reason, and it could be expensive. I don't think so for this application this could be expensive, but yeah, in most cases, so you should be familiar with that. So mostly you can directly import from the sync, and you can just import the like a standard level. You can just use import the mutex, but this is a Tokyo is a asynchronous runtime, so I'm just importing. So you are more familiar with that, and maybe in the upcoming videos you can also see the what is the reason importing that. For now, you can just focus on the CRUD version key, how you can create your own API. So like here we can just define the state, and we can just store uh, like how data will store. So why not? If I just we can't serialize why, because of I using the Tokyo, just include why this is a mutex that is actually log the data. So I'm just thinking for now we can just think and for now just okay, that is make sense. And that is actually store data, and this is data, and the data is I dot to string, and we just want a string, and we just pass the task state. Okay, and here we can return the actually return Or for testing, I think we can also print ln what the state. uh, I have a state, uh, or might be like that we can write task at state, and here we can debug, so for seeing all the data inside that, and here we can just pass the task, or instead we can write the state dot, or might be we can just pass the state, I think makes sense, and here we can return the okay, and it would be the JSON, and here could be the task response, I think, and here could be the pass the ID. What would be the ID? ID would be the task dot ID, and another is the message. uh, task created successfully, a task has been created successfully, and okay, and error it should be something like that. Error would be the like first the status code, so a status code, oh god, status code, and it is the, suppose that is already like task, like task, suppose it like what is in contains, suppose it not contains the hash, so to say okay, if already has, so it like same ID is from same ID data is creating, so it was saying it's like conflict, I think it makes sense. Conflict is just that data is already there, so that's conflict, like data is, we can return anything, like we can say hey that is 201, I think 201, like when you create a data, so it will return the response 201, I think. Okay, or might we return the 200, no sense, or might be we can return the, like here you can see the status, and we can also return something status here key 201 or 20, so it depends, right, what you want to return. Let's see, like what is this responding task, oh god, task response, and ID would be the like task dot ID. Task actually is not inside this, so first I just do outside, and here we can return the ID. Another is the message, and task is already exist. You know, ID always created by the backend, not by the client side. From client, it will only give the context or data. So created and ID will created by the uh, backend side. So it will do stuff in the next video in the for the creating ID in the, you know, how when storing the databases. So it is just understanding the CRUD application how it work, and that reason I just I'm doing this stuff. So here is the, it should be the to string. Task is already exist. It is saying hey, move your mode value tasks after move. So it is saying hey task dot id you can't access it because that is already moved data can be accessed. Okay. So task data dot id we are just doing stuff, and we can just passing data dot id data id here, and we just referencing data dot id, and here just inserting the data dot id keyword is start the data just convert the task string, and there is a task just returning. I'm just returning the data dot id. What is the data dot id? And here we can see like it's responding. So like everything is working fine. Like one thing I am thinking, like it will just, when you just create, it will just return the 200 because of by default. I think I should else well we can also pass the status code here. So basically when we create it, so it will return the 201. But for now, I can test it. What is how it is working, and 200 okay, and create task. I think that route is already been created. So create task. I think here create task post slash task task. So you're saying, hey, 405 message not allowed. So post and we need ID content exercise 6. Okay, chest exercise 6 May 2000s. Pandey Sachs 6 May 2026. We just oh god, not free account. So he is saying, hey, fail to parse the request but is JSON value number line. So basically it is saying, hey, this could be the U128, I think. And when it just enters field deserialize the column 6. What? Content context. Oh god, I just said the context. Context, okay, why? Okay, go, no worries. Content, context, or maybe your data, like anything. So task has been created successfully. Here you can see it is saying here 200, okay, but it should be the give the status code of 201, and next time is in 401 and complete task is already exist. So like 201 we should to show in the status code, but it is showing the 200 by default. So that cases we can solve by the here we can pass the like this. I think we then directly pass the same thing, like what is the function passing and what is the passing here, right? So like we can pass the same thing, uh, giving error. So this one come from like this one and it will give the actual data, like okay. So I just want to return the status code, and it is saying, hey, that is giving error because of we need the status code as well. And here we can pass the status code uh created created. And if I just control C, and I think should be clear, and cargo run and just test it. Test one task has been created solely, and here you can see 201 created. So basically when we write the status, so it is code, so it will just it will just convert it. It will go in the HTTP, I think, headers, I think, data contain content type application JSON cookie, I think I know. So header like status will go like here, and uh download to the software. So when you write the status, so it will go like in somewhere like here 201, like here we can just see, and body we can see the data like that. Headers we have can't like status code somewhere like save response. No, headers content type here. So that makes sense. Postman token, okay, buddy, okay, okay. So basically, when you write the status code, so basically you can see here. So okay, makes sense, make more sense. And here you can see the context chest exercise created, updated. So that is the task we just created, and now we can what is saying, hey, app HashMap we just created, yes. Task creation is done, and now we will go the get routes. So in the actually understood like why why can't give the like here we can't serialize because we are this is mutex and that is asynchronous. This is expensive, that is it. and it is if we can't slice it because we're just logging something, so logging the data, so that reason we can't do stuff. And this is the separate serialization, so basically just actually all the data, and this is actually a state, and the data is come from the client side. Or basically we can take data from the client, and we can just convert into that in this form, and we can store inside the databases. Yeah, anything could be, what the scenario, what the condition we should do. And here you can see, here we returning status code and different task response, and here you can see a status code as well, and we can returning as well for this thing controllers. So like creation is like completed, and now we can uh, go the uh, what is the next read task, read task, and get task, get task, get task, get task. I think get task is make more sense. Get task, and here we can first one pass the state, like what state is coming, what data ever state is that. So state, what is the state type, state, and state would be the like arc and JSON. Okay, JSON is nothing but just a get task. So for get task, get tasks, so we are fetching the all the get tasks. So I don't think we need to pass anything in a payload. So like we can take the ID, so for the specific uh, task, but I'm not going for that. So like for the task, so like get all task, get task, and get all tasks, I think make more sense. Get all tasks, get tasks, or might be we can write get tasks. So basically all the state here, and we not necessary to use the JSON, and here we can return. So ultimately we return the result, and by default the status got 200, right? So I'm not going with that, and directly we just return the JSON and task response, like task response is the Tesla message and the ID. So task response, I don't think to make more sense. I just passed to something else. So we can create like some struct for the struct for the get like a task get response, task get response. Yeah, might be task get all response, or might be task get response. So what would be the first is the like definitely message. I will write a message would be the string. Uh, or another case is the uh, another like data, I think, or maybe tasks. Task, it could be the something vector. Vector form is just it will just give in the array format, and this is inside the like a task a state task a state would be the task state would be this type, like task state is just all the objects, like all the data stored inside the value hash map. So key I will not include it, like only all the hash value has like value, it will just return in the vector form, like all the data will just like a grave, and it will just return in vector form. So we are passing message and and tasks, and it would be the just convert from the serialize, or anything we require. Task get response, tasks get response, tasks get response, get response, task get response, and here we can pass the task get response. So all the task get response will come here, and another we can pass the status, just the status code. I think that make more sense. If I just give the error, so what I will return? Like if suppose data is not exist 404 not one, so I think we should as well, I think we return the message some message. I think that is ID for tasks. No, that not make sense. I think we can directly what kind of message directly. Data is not exist or might be something. If not exist, so it not make sense. So if something error, so status code we can so. But here you can see it will also improve by the anyhow error, anyhow that is also error handling. So I'm every step I'm just writing a status code. So I don't want to write every time a status code. I want it can handle by automatically. So like what status code will come, what it is coming. But for now we can just focus on here and like get all the tasks, yeah, the first state and first log the data state dot log dot await dot on dot task we can access. And here you can see, okay, this is returning the hash map, and hash map we are returning, and we can return that. So uh, let tasks, and here can access it state dot uh, first we can keep we can write like that, or might be we can we have the default value, so we can directly return, we not necessary to return the error, I think. So it will directly return the get response. So if data is come, so if it's have the data, so like it's have the request, right, it's have the state, so basically it's a by default. So I don't think any status code is required, but yeah, we can return the status code that is error. Or maybe we can directly return the JSON task get response, not necessary to result. But for now we can just focus on that, like a status state dot log the data. So basically uh, state dot task, I think state dot task. Okay, task I already have. So we can now like get, and we can we can directly return this read data, so we don't think so much about that. So first we can print the state, like what is the data, like this I have the already all the state. So like I just want to print what is inside that task state task, and here we can just want to print what is inside the state. And here we can directly return the task. So like tasks state, like I want to access all the value, so values, and like it's come from the task state and string. I think uh sometime when you are stuck in the error, and you will think why this giving error. So like that was giving error, like I didn't give the cloning, and clone, and we are just doing the clone, so that reason it will give error. But in Rust, in when you are stuck, and you when you not take the, like when you not break the take the break, so and you're just stuck in the same loop. Why this is, and you try to find, okay, hey, I just want to fix this as soon as possible. So when you do stuff like this, like I was doing, so like you're just stuck on for many minutes, maybe hours. So yeah, I was just like here see a state. I just and here is the we are all the HashMap and task state, and we are just getting a stake, so we are not anything doing like rotating. So like here we are just returning, and that is data is a hash map, and like just extract the data, that value, and value, and here just clone all the data. So clone is nothing but just it will store inside the separate memory in the heap. So it will separate, like it will create the a specific memory for that, for the this particular here value, and it will store inside the heap. Like that is stored in the heap, and but it will just create a separate memory for that, and it will just collect in the form of the vector, and that vector is like a bake state. So that is returning. Uh, so okay, that get tasks, and we can just create the routes. Get task. What is the route like? Task and met. Oh God, task. Oh God, task. Method would be the, I think, get. Handler would be the get task. So here we can access all the tasks, and here we can just control C and cargo run, and then if I do this, so here we can see. So if I just create the task, and here we can see the body. So just created the task successfully, and next time we'll create it, so it is a task already exist. And now we just do the get, and saying hey, task has been faced successfully. That is the message, like, so task has been faced successfully, we can show in the UI. And here we can see like all the tasks here, the ID, chase exercise 6 May, the 26, you know. So we can update this one, and here we can see like 200. Okay, by default it will take by default. And if I just post and just write the ID2 and a exercise, and with the 6 May, and here we can type the 442, and another task has been created successfully. If I wrote task is already exist, and if I just go and get, and see exercise, here is the chess exercise, here the credit 6 May 332, 342, and the assigned successfully. So like this we can fetch the data. So here we can also see the responses, like here state task, task state, ID, exercise created. So every time we create it, so also see the data. So that is working fine. So that is the create task, and we can get task. Get task just log the data, and that is showing the state here, and we just string a state here. You can see like that is the most important thing. This is the cloned, like this is what is the value. So this is a hash map, all the value translated is just cloned, and we just collect in the vector form, and that was the reason giving error. So I didn't understand. So basically I just clone, like I just keep the here in a derived like line number 79. So like it was just also cloning. So that is that just did, and it is working fine. So when you stuck, so you should read the error multiple times to understand why this is error is giving. Or sometimes you also stuck, like you sub give some uh, not understand, like also used Axum handler. I think I didn't use like we can use something like Axum handler. So like some handler, I guess this Axum, I think handler, I think debug handler. So it will also define the, also give the what is error. I think I should to see it why it was giving. So here you can see cloned state collection value string is an iterator, right? So clone has my value string transfer iterator, which is required by mute cloned collection has my value string state etc. Doesn't satisfy iterator. So a little bit is telling you what you can do stuff. And here you can see consider annotating task state with derived clone. Here you can see also annotating a task state with derived clone. So the trait bound task state clone is not satisfied. Trait bound. So when I just just here you can see Axum debug alert. So that reason in a cargo.toml file I was just added that feature, this feature macros in the Axum. So actually it will tell you exact what as the error. So that reason when I just comment this, and you didn't find out, yeah, what this is giving error. I think it's giving error. Clone, okay, moving cloning error. drive with drive. Yeah, that I think Congress is saying same thing. So yeah, that I think I have no idea. You can just figure out what was the reason. So you can just think what. So it will do stuff. Okay. Control Shift Z. I don't want to do stuff. So debug handler work like, but I don't know, but it is doing something good. So clone debug stand clone. Okay, everything working fine. So you can test your answers. Sometime previous data stored inside the cache, so that reason also give the thing. But debug handler is main purpose is like it will tell you what is the exact error and how you can check it out. Well, how you can find out, right? And how you can fix it. So yeah, that is important, and you should to understand task already exist. So okay, so yeah, I read is uh, I think get task have the getting task, and now we are accessing the specific not get task by ID. So first I just want to do the update async async function update task, and here we could pass the state. As state would be the simple state, yeah, state. And what would the type would be the state and update task. So basically I need to the actual data actual state. So what is the state? Definitely I need the arc, and I have a state, and another is the data is come from the client side, so JSON. And here we can pass the type. So what is the type here? So data type is the like task state, I think. Task getter, task state. So basically I need to pass everything, so it will update. And we are doing a put. So put, it will just do it like uh it will update the right particle, in a it will put update just a method, but the put have the replaced all the data that was previous. And if I say just the what data you just updated, previous data will previous data will keep in the table in the database, in the like is like you can also use the get method and you can update the data. So it depends, but every method have the purpose. Okay, so update task. So like okay, so update task. So what we'll do first we'll first state, and first log the data. So state dot lock dot await. Why update is showing? Because of we are using like mutex is coming from the Tokio asynchronous, and it is expensive. So that is the log and wait. And what is the data? After that, yeah, definitely you can access the data task. And yeah, we can access and update tasks. So first we'll check the data, it exists or not. So definitely I will mute the data, right? So mute the data. If okay, update task. So first I will check the data uh, like some ID is exists in the HashMap or not. So I will check the state dot contains key, and what is the key? Data dot ID is existing or to a string, I think. If not exist in the hash map, so I will return the data. So what if we are returning? So like this one, and we are not returning anything. Oh God, we are not returning. So result, and here we can return the JSON, and by default, yeah, definitely we return the task response like ID and very successfully. Let's just a message, and and like update task. So here we can uh, like error. So error what we do like we can. I think I should return the status. So I think both. I think a status code and task response like ID and message. Oh, I think like what is the like what ID is not updated or maybe it not exist. So here we can task response, and if not exist, so here we can tell hey this is error and a status code. Status code would be the status code um, not found, and here we can return the JSON and task response ID would be the data dot ID, and it will be the message. Okay, 32, and another is the like message. So we can tell hey uh, task doesn't exist. Why are you operating, right? Task doesn't exist. Twisting. So it is saying hey it is giving error. Can you tell me why it is giving error? Okay, what is saying? Hey, remove the parenthesis. Oh God, where is the parenthesis? Here is the error. Error. Okay, we status code and error have like error like two things like two arguments like that like result have okay error, okay and error. Error have the like we can pass but inside the one uh you know in the one parenthesis, not more than one. So okay error, so it is saying okay that is not exist, so good then just you just update the uh, you just return the miss draft doesn't exist. I suppose it is exist, so I will tell you instead of doing like first you should to define the let task and task like uh, task state I think, and ID would be the data dot ID, and what would the next context data dot context. What is the next? Created at data dot context. Created at updated at. What is updated? Data dot updated at updated at. So that is the updated. So just store and we just define, and like if I just go here and else like I just want to update, so we can do state dot insert, like we can do is like we are just replacing like put and patch. The put is just replacing all the data and it will just update the new data. Patch is what is inside like what the key what is inside the particular thing, it's not inside that store, so it will just update the best like particle particle thing like very like 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 key like multiple things like it will just replace all the data and patch is just update the specific part. That's it. And insert would be the like id dot string, id dot to string I think. What is the data is come data dot id and dot to a string, and another is the we can just update the task. Okay, so okay, and here we can return the json, and json have the task response, and id have the data dot id, and message have the uh, task has been created updated successfully, and it dated to a string, so we return to a string. So basically here we can see that we directly updating the whole the data, and now we can it is saying hey that is the giving error, so we cannot move out the dereferences. So dereference of Tokio is was sync mutex guard move occurs because value has type has map string move occur because value is type has map string task type which does not implement the copy trait. So consider boring here, consider cloning the value is the performance cost. So yeah, when you clone, so it also uh, give the like suppose you are updating if you're just cloning here no, so it will create the separate memory in the heap. So if you updating what it will not updating actual data. So that cases we should to understood why it is saying hey you should dereference. What is happening? Okay, cannot dereference. Okay, cannot dereference. Understood. So what is giving? Why is giving? So cannot borrow. So is a mutable as behind. So reference state is a reference. So the data is referred to cannot be borrowed as mutable. Changing this mutable reference. Mute. Consider changing this to be mutable reference. Mute. Okay. I think we what? Oh God. Uh, First focus. Why this giving error? So like what I'm doing is like first I just state and state is just uh, taking the state archive state data JSON task state returning. So here is the mutable state and we are dating. So if I are updating the data, it means the be should the owner of the data. So yeah, be should the owner and then what is saying cannot move out the reference Tokyo sync mutex guard move occurs because of hash card is trusted which does not implement the copy trait. Consider boarding here and cost performance cost is the do the stop. So wait and if I instead of that if I just remove the task and we are directly like we are just mutex guard and if I do just just task so it is returning HashMap. So instead of that I just await like just matrix guard state. So that is important and state dot 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 task I think yes contains key and state dot tasks dot insert. So that is just the mutex guard task state. So sometimes we also focus the pattern what actually we have and we should act on that instead like if I have some rule line we should to follow that rule line what we can do that is so important. So we are just mutex guard and mutex guard like we are just returning the value so it doesn't make sense. So that is mutex guard and this state here you can see
It's
like
4 o'clock.
here just that already data is locked and we are just updating a step updating a state but here you can say key it is saying hey it is giving error like it's saying hey like how like trait is something else cloning stuff if I just clone it differently data just create the separate memory so it didn't make sense it will not delete. So that reason I just wait like wait nothing else like you just separate this thing okay and just remove the task and what is important so we just did it and update task so control C and update task. Sometimes you can also think "Hey, why this is giving error." So that is the reason. So when you don't understand the error so you are feeling okay and some most important thing if you just didn't experiment just I just copy paste you didn't understand why this give and you can just change the code like you just add the task why in a get us just add the task. So it we are just reading the data I'm not any mutating the data so that case we just rather with task and here you can see likely return the hash map but here we can actually mutate the data so that reason I just wait and see okay contains key and go inside that. So basically this is a state that is actually mod mutex card actually log the data And so this should to add the router. So router would be the what is the router update and due to the put here can put the update task, and put is coming from the routing gate. I have already talked before in the previous video. That is a routing. A state already talk about a state query JSON. So if I just control C and cargo run and just go here and definitely we say okay, task has been fetched it should giving the task and fetched successfully and it have no task. Okay, you can show your message. So like task 1, task 2, task 1 uh coding. Okay, task 1, task 3 reading, docs. Okay, and now we can just go get and we can access, we can read the, we can see the data like 1, 2, 3, reading docs, exercise, coding. And if I just go and put and like I just want to update the coding to coding to what the coding to like I will do the chest exercise and just task has been updated successfully. If I do the same, this will directly just update it, nothing will change. And if data is doesn't exist, like suppose if I'm what I'm doing like content exists, so like updating, right? Suppose data is not there like 13, so task doesn't exist, 404 not found, and if one, so it will directly update 200. Okay, so we can also read the data and here we can see like uh, this data is updated. So that is the update. And now we have the last is the delete. So delete is the easy, but yeah, let's see. Async function delete task, and here we can see first one the delete task. So first we need a state. What is a state? A state would be the like we can give the name in. And what is the type? Start type is the what is the type? It would be the arc. This arc is just the reference count, in case the reference count how many owner, and with the state we if we don't give the base, so basically for every routes we uh, share the state to every routes. So we not necessary to pass like that, but yeah, we have the state arc and what is the type? What is the type? What is the type? I have a state. Okay, I passed it. That makes sense. Okay, delete us, and here you can pass the actual ID. So you need the ID, and here you can give the name, and that is the uh, task ID. Mm, in a previous video, I also talk about key. When you pass in is like struct. So you can give anything, and you access the actually name of the like path name, like it's of the more the type shape. But here you can pass the task ID. So basically, it will work like the tuple, and like you can access it, params like that. And you for more definitely should to recommend that video. So like in path, and here we can path 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 path. So path, yeah, definitely path. So what is the type? This let's see query, just give the name task. What is the task ID? Task ID would be the like U32128. It could be anything like U8, U60, U32. You could give anything name. and result would be the first one is the response delete task. JSON and task response by default we should give, and error would be the status code. I'm not returning anything. I like message ki hai delete successfully. We can return the ID and delete task, but it depends. But you can return your message, but I'm not returning. I'm just returning the status code. And first what we do first. Definitely we first log the data. Okay, so first log the data state dot log dot await we have the mutex got. So like updating, so we need the like mutable like updating the data. And now first I will check, hey, state is exist, like is contain that key is exist or not. So first I will check, hey, task dot contains key is exist, like contains key. What is the key? Key is the task ID. Oh god, task ID, I'm telling na. To string. Oh god, contains key. Okay. To a string, and we need to give the uh, reference count. It is saying like something error. That is the task ID, task ID, and to a string. That makes sense. Task contains state dot task contains key task ID dot string, and then uh, is thing something error. Path is a task ID, and it is saying remove unnecessary generics. Remove unnecessary generics. So we are passing something generic. So what is the here is a generic. So like here just use the path, and here just give the name like task ID, and here just path the path, and here pass the U32. I'm not doing anything wrong. Everything is fine. And see where is coming from the path. Path is coming from the std collection. So that reason it is giving the error. So basically it is not error, but what where you are importing it is also important. So a path and a path state is come from the extract, not the string library. So that reason that was giving their query how you extract the data. So that is also important. And now you can see like error is caused, like error is gone. So task ID that task ID. So it is saying what is problem? Attempted value to a string and type U32. So how you can do this? So status task ID. For task ID is like uh to a string you should to call the function, and we should give the reference, I think. Yeah. So when to a string converted to this is a function. So if I am calling here, and this is the reference. So it is not taking the actual owner, it's just taking the reference. And if you just take hey that uh, a keys exist or not. If suppose key that exists, keys doesn't exist, so it will give the error. And I am just returning the status code, and like not exist, I think. Not exist, not extended, not found, no content, no, not found, I think makes sense. Not found, I think. Okay, not found. You just directly return the not found, nothing else. And no, why? Uh, expected enum class should give the illness class, and if I not return like if class, तो should return the else class. ठीक है जी, इस class return करता हूँ ना, we can do the else class. So okay, and what is the type JSON, and before do we should the delete. So state dot task dot remove remove ID. What is the ID? ID task ID, na task ID dot to a string, and it is saying here is you to pass the borrowing. Okay, we just pass the task state or task remove, and it will just remove the data, and we can directly return the uh, data. So what is the best by default? What is return task response ID? What would be the ID? So okay, remove, and we just return the ID. What is ID? ID would be likely the task ID. I think that is just to a string, I think. And it is giving error. Why? Expect you. Okay. You need the u to it, not the to a string. No necessary to convert into that. Uh, okay. Task ID path 32. Okay, we need the u1 to it, and you are just passing the path. I'll just change this now one to it. Why you thinking so much? And deleted task deleted successfully. Task deleted successfully, and it would be a string to string calling. So basically, it will just delete stuff. If not found, it just return the status code and with no content. And just delete task and control S, and we just go the routes, and we can just clear the routes, and slash task method would be the delete, and it will be the oh god, delete task, what is that? I think makes sense. Now makes sense. Now makes sense. Yes. Now. Delete is not here, so basically we will also import this one from the routing as well, and now we can test it. What actually did, like, we just log the data, we already know. Okay, first log the data, feed, then a status code, like contains key or not, like already exist or not, so not return not found. And basically we are doing this line like state dot task dot remove, like basically we are just removing the from the hash state, and we are just returning the response. Another thing was like we are just waiting, so waiting is just returning the mutex card, so that is, it will not give error. Otherwise, you can return a task as a state. So, it give the error, okay, why you doing this? So like that. So you should to understand as well what I'm doing, when to stop, when to pause. Like, here we can't do this like we do, but it will, borrowing and reference error give error, and you will figure out like what why. Sometimes you feel okay, that is I'm not understand. So sometimes you should to understand. It will come from the experiment. So okay, now I just want to test it slow. Like we have the task, not task. So first we'll create one test exercise, and second ID would be the abs exercise. Another is the सबसे hard exercise, leg exercise. Oh my god, leg exercise. Task already exist. Okay, so another is the get, and we can see okay task and fetch successfully. We have the 3 ID. Okay, we have the audit data, so basically we are stored inside the hash, and it will just converted into the back, and that cases we just especially I remember what was the error. So basically I just gave the clone, and another was like it can be optimized as well. So here, so basically that is the task, the vector, like vector state. So we just extract the data only value, so all the hash map have value, so like all the values come, and like just clone the data, like just honor, like we just as for understanding this, some clone less like clone is just like create a separate memory space, and then we just collect like what the data types in the return. So this is a task, and that in that form. So basically we did it. So uh, so that is a get method, and now we just put it just updated data. Like suppose we want to update the theory, like theory leg exercise to the like what another exercise, like simple exercise, and just update, so task has successfully. Okay, so now we can now access the all the data. So like we can access like simple exercise, and if you want to especially like delete the uh, task, so it will not delete because if it doesn't miss it allowed. I think wrong number path arguments expected one to got. So basically we need to some pass like some ID here, but wrong path expected one got to 0. So basically Axum really care about types, so what types is necessary, so we need to pass, and we are just giving the like routes, but I didn't pass the uh, actual routes, like what is the ID. So basically here we have the ID, path ID, and now we can just do stop like control C and cargo run, and we can just now can see it like we can just post, and task has been created, another like one apes exercise one, another is a two, and this would be the chest exercise, chest exercise, and now we can access the all the data. Task has been created 1 2 3, right? And now I want to update the data. So basically I want to update two chest exercise to the top exercise, like leg exercise. Task has been updated successfully, and we want to exercise, so it will give the all data and like leg exercise 1 2, and like I want to delete this one, so it will say you should give the 2, and it will task did successfully 200. Okay, and if you say okay 404 not found, it doesn't exist, data is not exist, so it will not give, it will directly give the 404 not found, so doesn't exist. So that all about, and you can create your routes, right? Basically you can create the you can access the data by the ID, so you will create one like like a specific ID. We can just like only pass the ID, and you can access the data, like we have the get task, so you can create the routes like only that will instead of giving the all the tasks, so it will give the specific task, like particular task, so you can create your own task, and this is uh, your when you write yourself right now, so definitely you will understand more. So that's all about. And next video basically we are storing inside the app state, so instead we will store inside the database. Basically I will create the schemas little bit, yeah, definitely we need and we run the docker in the backend, like Postgres we will run in the docker form, like dockerize, and we will store inside the data, like we locally we can test it. And another after next video I will create talk about the CI/CD dockerization, and after that I think deployment might be okay. Let's see what would be the next, and you can comment it, and what will be the next video, and also you can comment where is the problem you faced, and where I can improve as well. So sometime also confused, I think might be yeah. So yeah, let's comment it, and I also you know like I will also improve that. I'm not the expert, I'm not master in this, so I'm also learning and exploring, and I also I'm not good at the explaining, I know. So you can comment as well, so I can also like which part, which area I can focus on that. So next video, let's see. Okay, let's see. I will meet you in the next video. Thank you so much.